Hello, it's good to have you here. I love to tutor. This question is on page 168 of Functional Mathematics for Senior Secondary Schools by T.M. Asiru et al. So the question says in figure 10.46, QRS is a straight line. Line QP is parallel to line RT. Angle PRQ is equal to 56 degrees. And angle QPR is equal to 84 degrees. And angle TRS is equal to X. Find X. Okay, so now angle QRS is a straight line. Okay, and then line QP is parallel to line RT. Line QP is parallel to line RT. And then angle QPR is 84 degrees. And angle TRS is angle X. And that's what we've been told to find. So now we have to take note of the parallel lines, angle QP and angle RT. So let's look at our parallel lines. Now, between these two parallel lines, there is a transversal line PQ. And remember, at the points of intersection between a transversal line and parallel lines, angles are formed, and between these angles there exist relationships, and there are theorems around these relationships. So now we have that angle QPR, which is this angle, just this angle. Let me represent it. Just this angle, 84 degrees, is because this angle, this QP is parallel to line RT, and you have this transversal line cutting across both of them. So this angle QPR, which is 84 degrees, is alternate to this. So we can say that this is also 84 degrees. So it's important to write it. We write that angle. So this angle now is angle PRS. That is angle QPR is equal to angle RPT. RPT. And angle PQ, angle QPR is equal to 84 degrees. It was given to us. So it's also in, since angle QPR is equal to angle RPT, so angle RPT is equal to 84 degrees as well. Now then let's look at this straight line QRS. Sum of angles on a straight line is 180 degrees. So from this point to this point is the whole angles here. So here you have on this straight line QRS, on line QRS you have 56 degrees plus 84 degrees plus angle TRS, which is our X, TRS. So, and it's supposed to, the total of this angle is supposed to give us 180 degrees. 180 degrees, sum of angles on a straight line. So that you have that okay, 56 plus 84 should give us this is 13, okay, 140 degrees. So we have 140 degrees plus Angle TRS is our x, which is 180 degrees. So that our x is equal to 180 degrees minus 140 degrees. So our x is equal to what? 40 degrees. So we have found our angle TRS, which is equal to x, which is equal to 40 degrees. This question is on page 168 of Functional Mathematics for Senior Secondary Schools by T.M. Asiru et al. Functional Mathematics, Book 1. So the question says in figure 10.47, in that figure there, NP is equal to NO and MC is parallel to OP. If line MNP is a straight line, calculate angle X. So NP, look at NP. Look at line NP. Line NP is equal to line NO. So what this implies is that this triangle NOP, is an isosceles triangle. So for these two sides to be equal, it implies that triangle NOP is an isosceles triangle. And there's a theorem on isosceles triangle. An isosceles triangle has each base angles are equal. So if this NOP, if NPO is 50 degrees, that means NOP will also be 50 degrees. So now okay, I think we should just start solving now. Okay, so now angle, okay, now sorry, since NO is equal to NP, it implies that triangle NOP is an isosceles triangle. It's an isosceles triangle. So now, for it to be an isosceles triangle, its base angles are equal. So since it's an isosceles triangle, then angle NPO is equal to angle NPO is equal to angle NOP. And look at angle NOP. This is angle NOP. This is angle NOP. This is angle NOP. Sorry, this is angle NPO. So, and since angle NPO is and angle NPO is what we have as 50 degrees. So it implies also that angle NOP is equal to 50 degrees. So let's just write it for clarity. Sorry. So this is 50 degrees as well. So now it's also given that MC is parallel to OP. MC is parallel to OP, and between MC and OP, you have this long line NP, MP, MNP, MNP, connecting the parallel lines MC and OP. So now, if you have this transversal line cutting across these two parallel lines, it means that this angle NPO, which is 50 degrees, is alternate to this angle here. So alternate to this angle here. Let me present it. It's alternate to this angle. So since this is 50 degrees, this as well is 50 degrees. 50 degrees. Alright, so now with this, there's another theorem on triangles that the sum of two interior angles is equal to an exterior angle. So now look at this. This is a triangle. MCN is a triangle. MCN is a triangle, and the sum of two opposite interior angles is equal to an exterior angle. This angle and this angle are the interior angles of this triangle, and the sum is, both of them are opposite to this exterior angle. This angle is outside this triangle, so the sum of these two opposite angles, of course you can see, is opposite to this x. So now you have that angle. This is angle C, angle CMN, angle CMN plus angle MCN is equal to x. Reason is that the sum of two opposite interior angles of a triangle are equal to its exterior angle. So CMN is 50 degrees. CMN is 50 degrees plus MCN is 78 degrees. 78 degrees. So it's equal to our x. So 70 plus 78 is 128 degrees, which is equal to x. So therefore our x is equal to 128 degrees.